Hi, hello, vanakkam, and welcome back to yet another interesting episode on Little's Law YouTube channel. So today, we all know in this series of videos we were seeing about how to perform or how to do a load test, starting or dividing it into different phases of testing. So we started it from identifying the test environment, and then we have identified the performance metrics with the response times of, or we would say, the SLAs of the performance testing, which we have to collect after the test, at the end of the test. Or in the phase 3 we have designed, or we have identified the scope and out of scope, and then we have identified what are all the transactions which we are going to test, and then what are all the servers we are going to monitor, and what are all the scope and in scope, and how are we going to do a test by identifying the number of users and the duration of test. And next we have configured the test environment by finding what are all the requirements we have and how do we collect that. And then in the phase 5 we have designed the script. So I have taken you through the designing of the script, where we saw about how to parameterize or how to correlate or how to create scripts. And then in phase 6 we saw about testing the load, or doing a load test with multiple different thread groups. We started with the normal thread group, and then we ran with the ultimate thread group, and then we ran another test with running based on the number of hits. So we have explored a lot. In fact, there are much more to come, but still I would like to share you about the results. So how to analyze the results. So in this video we are going to see how to analyze the results from Jmeter at the end of the load test. So this video is completely going to be a load test for the run 1 load test response time analysis. And so this is how we will collect the response time. Say for example, if we are completing the test, and after completion we will have to list down the transactions and their minimum response times, their maximum response time, their average response time. And in case if you are required, or if you're asked to collect the 95th percentile or the 90th percentile, please do collect them. And then here we collect the number of hits for each of these transactions. And here, so this is completely an example, so I'll just take you through this. And then here we have the past transactions and then the failed transactions. So I just want you to understand in a real world performance testing environment. So that's the reason I have brought this kind of collection for you to show. And before we move on to analysis and how to create a report, this is me, your Vasant Shanmugam. I welcome you all to our Little Sly YouTube channel. Please do subscribe to our channel if you have not subscribed yet. Like, comment your questions and feedback in the comment section. So now let's go to the phase 6 of testing, which is the load test analysis. So here, so we have completed one run of load test, and in the phase 7, so which is going to be the analysis, report and retest. So now, so this is usually the format how I share the results to the client. So this is just a basic, a skeleton, I would say. If you want to add or if you want to remove any of these sections, please feel free to add or remove any of these sections, and make sure that it is more presentable, and anyone who sees or reads it or who goes through it, please make sure that they understand it without asking you any questions again and again, like coming back to you and asking like what is this and why do we need this, or how does this helps the application. So make sure it's not up to you that it has to be presentable, but it should be more understandable to the stakeholders. Okay, so let's now see. So this is an example test or example metrics which I'm going to show you for one of the load test. So here we would like to, or we should tell them that what is the duration of the test. So for example, in this test I'm telling them the total test duration is a 2 hours test, which includes the ramp up, the steady state, ramp down, before and after, everything. So I'm telling them the total test duration is 2 hours, and then we'll have to, or we should tell how many users we have used for the load test, the total virtual users, because this will tell them clearly that with how many load or with how many users we have executed the test. In case if they really want to increase the load, they can easily scale up or scale down based on the results. So this is very important. So these all these test summary is very important, and we have to make sure that we have everything set up here. And then the next thing is the total number of requests. And so the total number of requests, which is the past, or which has to be the summary of the sum of both the past and the failed transaction. So that is the number of requests sent. And then when it comes to the environment, so we should tell them that which environment we have executed the test. Either it is a pre-prod, or it is a sit, or it's an UAT, or even it's a dev environment. So we should tell them clearly, because based on the scalability, or based on the amount of resources the environment has, is another factor that decides the performance of the application. So we must tell them clearly that which environment we have tested it. So in most of the cases, in fact, in test plan, we will give a table which tells them that we are running a test in a pre-prod environment, and what is the size of the production environment, and how much, or what is the ratio of the pre-prod and the prod. So this will in fact give them a clear understanding of how well does the application behave. So for example, if we want to achieve 2-second response times, so what, and the pre-prod environment is 1/4 of the production environment, and if you get a 4 second of response time, then that's a good response time, because when you scale up and scale down, that level of response time is a good response time. So that is how we, are the business, or the business analyst, will define the SLA. So when it comes to SLA, we call it a service level agreement. So that is how we define the response times. And then when it comes to the test type, so we'll have to tell them that whether it is a load test, or whether it is a stress test, or whether it is a smoke test, because in most of the cases we will have to run a smoke test, and we will be giving them the results like this. So we'll have to tell them whether it is a load test, or a stress, or a spike, or whatever it is. And then when it comes to the execution, so usually we will run a minimum of 3 rounds of testing with the same setup to have an apple to apple comparison of the response times. So in this example, I'm telling you that so this is the first number, the first execution of load test. So in case if I'm running a second test, I'll have to give a comparison of the response times for both executions. So now we will see in this example of the analysis, for the analysis of the results. So we are done with the test summary. So this is done. So we have completed the test summary. Let me change the colors. So we have completed the test summary, and now let's move to the response time table. So when we come to the response time table, so here we can see we have got 3 scripts with different transactions. And when you see here, we can see for the login transaction, the minimum response time is 1.8, the maximum is 2.5, and the average is 2.1. And we were able to achieve 200 hits for this transaction, and the past transaction is 195, and then the failed is it's just 5. And then the same way for homepage, category, product, and logout. So when we see the response time, we can see the difference between the minimum and the maximum and the average. And here we can see the difference between the minimum and the maximum is around 0.7, and the difference between minimum to average and between average to maximum, it's around 0.3 to 0.4. And the same way, when we see for every different transactions, it has to be an acceptable level. So what do you mean by acceptable level? So for example, when we see here, the minimum response time is 1.8, and the average is 2.1, and the average is 2.1, and the maximum is 2.5. This is an acceptable level of response times. What if an unacceptable? So when the minimum is 1.8 and the average is 3 and the maximum is 5, or the maximum is 4, so there should not be a huge deviation between the minimum or the average or to the maximum. So it always has to be, or the deviation, so we will normally call it a standard deviation. So in fact, I would recommend you to add another table where we can see the standard deviation between the average and the maximum, because that will tell us whether there is any bottlenecks. For example, if the average response time here is 2.1 second, and if it is and if the maximum response time is 5 or 6 or even 10, so that is a bottleneck. And this one that we see here, the maximum response time, which is 2.5, which is not even, I would say, 20 or 10, or it's like 10% of 10 to 20% of increase in the response times. It should not be like 200% of increase, or it should not be like 300% of increase. If it is less than, if it is below 50% of a deviation, then it is an acceptable level of performance response times. So that's how. So again, when it is 1.8, so, and when it goes to average, it is almost, so in fact, this minimum response time, which is 1.8, and the average response time, which is 2.1, is almost 20% of increase. And again, the same way from average to maximum, it's around 10 to 15% of increase. So this is an acceptable level of performance or the response time. Again, the same way for every transaction. And again, talking about the past and the failed transaction, so first we will have to identify the failed transactions, and in this particular results we can see out of 195 or the total 200 transactions, 5 transactions has failed, so which is less than 2% of the total test. And the same way again here, it's everything is around, is less than 2% of the total number of hits. So for example, if it is 400 and if it is just 10, it's around 2% of the total number of hits. 2% have failed. So in fact, if this particular, or if the failed transactions are high, so that indicates that there is some performance issues or errors. But in this case, it does not pop up like a bottleneck. So for example, if we are getting failed transactions of almost 20% of the, say for example, like if it is 300 400 here, and if the failure is like almost 50 failed transactions, so then that is a bottleneck. And again, we should know, or we should see what are the errors that we are getting. Either it is a functional error or it is a database error. When it comes to functional error, so in some scenarios where we might be making some typo in giving some data in the application, and that might be keeping this transaction a failure. Or in case if this is something like a 400 error or a 404 or a 302 or 500 or a 503 or 502, so either it can be a server error or it can be a client error. So we should in fact analyze the transactions, like what kind of error or what was the expected response and what is the actual response. So all these things has to be identified. And in fact, it's not just the numbers, because this numbers tells us what exactly is happening in the backend or during the test. And this in fact will, the exact thing will happen when the real-time user experiences the application. Because in most of the scenarios where when we were trying to book a ticket, or when we are trying to book a theater ticket or a bus ticket or a train ticket, so the application might go down. So this is the scenario that happens due to the performance issue. So we should be very clear, and we should understand that if something is failing, we should note down that, and we should do a detailed analysis to see whether it is a server error or whether it is a client error or whether it is a functional error. And the next thing is, we should see, say for example, if there is a huge amount of failures, we should again start analyzing the response times. Again, I told, the error messages and any other relevant information has to be detailedly analyzed, because this actually helps us to identify the root cause of the failure and suggest any potential solutions. So how to review the past transactions? So far we saw about the failure transactions, because failure transactions tells us that there is something wrong. So what about the past transactions? What do they tell? So the the past transactions may not have experienced errors, but they still have response times that are slower than desired. Because even though we can see a lot of transactions that are passed, but that should be correlated with the response times, because it's not just only the passing the transaction. Because for example, if we are using an application, and what if the application runs for a long time, even though it passes, or even though if the page gets loaded, or even though if the page is working fine, but what if the response times are high? So we have to analyze even the past transactions, because that will tell us the areas of the application that are experiencing the performance issue. So anything that is high, or in other words, you would say if there is any spike even in the response times, or even in the past transactions or in the failed transactions, we should note down that, and we should correlate, and we should examine with the performance time, and we should see what exactly is happening in the backend with the results. And the next thing is when, so what is the acceptable criteria? So how can we accept it? So we have got the response times here. So what are, on what basis we say okay it is accepted or it is not accepted? Because it's not that we're running a test and just giving the results and that it's over. So it's not just like that. We should give a result and that should be accepted on a criteria. So we should review the performance objectives for the application to determine if the test results meet the desired performance criteria. And these performance criteria should be collected during the initial phases of performance testing, that is during the requirement collection. And if the test results did not meet the objectives, we should further analyze the issues and we should tune them based on the requirements. The next thing is we should collect, or we should have an SLA for the performance testing. Say for example, if the minimum response time for this particular script should not pass 3 seconds, and if the maximum should not pass 5 seconds, and if the average should not pass or should not cross 4 seconds. So we should have a clear understanding of the SLA, and if something is crossed, then we should start analyzing, or we should find what and how is that happened. So we will see that in our next video. Like for example, if something has crossed the response time, so what are all the possible scenarios where it might cross this the response times. So this is an example. So this is how you have to create the response timetable, which should have the transaction name, the minimum response time. If possible, you can bring the average response time in the middle and then the maximum response time, and hits for each of these transactions, and then the very important one, which is the past transaction and the failed transaction. So now, so we have completed this. We have completed the, and now let's move to the next part, which is the CPU or the memory. So this CPU, memory and network is another important criteria when it comes to the performance testing or the performance engineering, because once you start analyzing these, you are moving to a next level of performance testing. So I would say mostly into the performance engineering. And in this scenario, so most of the scenarios we will not have one single server for testing. We might have 1, 2 or 3 which will be divided with the load generator. So this is how we have to analyze, and in fact if there is a chance of doing it, please do analyze the load generator, like how well does the load generator has been distributing the load. So in this scenario we will see, so we have metrics for 3 different servers, and we can see that the server 1 had the highest memory utilization, uh, reaching up to 80%, while server 2 had the lowest memory utilization, only reaching up to 70%. Server 3 had the lowest CPU utilization, reaching up to 30%, while the server 1 had the highest CPU utilization, reaching up to 40%, and all the servers had similar network utilization with an average of 150 kilobytes per second. So based on these 3 metrics, we can see that the server 1 may require additional memory resources to handle the load, while the server 3 has enough CPU resources to handle the load, and server 2 had relatively low resource utilization across the board, indicating that it may be over provisioned. So overall, these metrics can be used to optimize the resource utilization for each server and ensure that the system can handle the expected load without any issues. So there is another side of this performance testing. So here we could see that the server 1 is highly utilized and server 3 and 2 are not highly utilized. So in this scenario, what might have happened is the load generator which we have set up might distribute a lot of users to server 1, and so once it started to distribute a lot of users, so automatically very less number of users might be using server 2 and 3, and in that scenario server 1 might be processing too much of the load. So in this scenario, again, if this is what is happening, then we should go back and we should see, or we should examine the load generator configuration, and we should optimize that in a way that the servers, all these servers are equally distributed with the resources. So this is how it works. And then finally, so we have completed the analysis. I believe this will definitely help you in your analysis part. And then see the overall analysis, where you will have to come up with the points that tells the reader or the stakeholder that is the test passed or failed. So I'll just come up with the another set of the overall analysis statements where you can use in your reports. So we will see that in a different, in our next video, which will, so this is overall a happy result or a happy ending result, but I don't want to give this as an example this next time. So next time we will see a completely different, a messed up response times. So which is most of the times which happens to the performance testers, where they get a response times with high response times or with a huge deviation and a CPU utilization, a deteriorated CPU utilization. So we will see that in a different example, and we will experience the real world of how well does the performance testing works. So until I meet you in our next video, it's bye bye from Vasan Shanmugam and Little's Law. Please don't forget to subscribe to our channel. Keep watching our channel and keep following our channel.